Hello friends, welcome to video series on geography. In my previous video I've explained about atmosphere. In this video I'll be dealing with temperature distribution and the text files available on my blog. So in climatology the core concepts are atmosphere, temperature distribution, wind and pressure systems, water cycle and climatic regions. So atmosphere is done in the previous video. So the temperature distribution is also an important concept in which we'll study about heat budget, latitudinal heat balance, etc. In wind and pressure systems, we'll see about different kinds of winds, namely permanent, seasonal and local, as well as we'll study about the core concepts of wind and pressure systems like equatorial low pressure belt, polar high, and then we have winds called as easterlies, westerlies, trade winds, etc. And in water cycle, we'll deal with precipitation, different kinds of precipitation or different forms of precipitation. And in that, we'll see about thunderstorms, tropical cyclones, and temperate cyclones, etc. In climatic regions, we'll see about different climatic regions and biotic regions. So we'll talk about important climatic regions like equatorial region, and then we have desert region or arid climatic regions, Mediterranean regions, etc. So in today's video, I'll be explaining about factors that affect temperature distribution on Earth, and then we'll see what is heat budget, and we have another important concept called as albedo, and finally we'll see about latitudinal heat balance. So in climatology, the core or the main concepts that forms the basis of climatology are temperature distribution, both wind and pressure systems, and then ocean currents. Though ocean currents are a major part of oceanography, but still I'll be dealing them in climatology because ocean currents influence greatly the temperature distribution on Earth. So it is better to study ocean currents before we get a complete picture about temperature distribution, because these are all interconnected issues. So we need to study based on the priority according to which they affect the temperature distribution on Earth. And then if you see, the wind systems are directly related to pressure systems. It is due to pressure differences winds are generated, and then pressure systems are in turn created due to wind systems. And wind systems affect the movement of ocean water in the form of ocean currents, and ocean currents again transfer heat from one latitude to another latitude, creating a temperature difference, or sometimes it even leads to temperature balancing. So all these factors are interconnected. So these all needs to be understood in a very good detail to understand temperature distribution on Earth. So moving on to temperature distribution on Earth, we know that Earth receives all its energy from Sun in the form of light, and some amount of energy is received from interior of the Earth, but this energy is highly negligible because it is in very small quantities. But the major source is Sun. So we receive Sun's rays in the form of shortwave radiation, which is also called as ultraviolet radiation. And Earth is like a heat converter where it receives light and it converts it into heat and radiates back into space in the form of long wave radiation. So long wave radiation is nothing but infrared radiation. And the heat transfer between Sun, Earth and various regions on Earth takes place mainly due to three processes. One is radiation, other one is conduction and convection. In radiation, there is no movement of particles, or even we don't even need any medium. For example, that is how we get sun's rays from Sun to Earth. And in conduction, the heat transfer is mainly due to molecular activity. There is no visible movement of matter when there is conduction. For example, how heat is transferred from one end of the iron rod to other end is an example for conduction. And then in convection, there is actual movement of matter, like we see in the boiling pot of water, where the water at the top, which is denser, falls to the bottom, and the water which got hot at the bottom rises to the top because of reduction in density. So these are very important ways in which heat transfer occurs. And to understand about short waves and long waves, let us see this electromagnetic spectrum, in which there is different kinds of waves based on their wavelengths and frequencies. So coming from low wavelength to high wavelength, the waves with least wavelength are gamma rays. We can see the magnitude of the wavelength, and then we have X-rays, and then ultraviolet rays. So these are the rays which mainly strike the Earth in the form of light. from the sun. So they are called as short wave radiation because their wavelength is comparatively shorter compared to visible light. And the other one is infrared, or it is also called as heat, because infrared radiation is nothing but heat, and infrared radiation has wavelengths greater than visible light, hence it is called as long wave radiation. And then we have microwaves and radio waves. So this order is very important, that is increasing order of wavelength or decreasing order of frequency. And we need not remember all these numbers, except that for visible radiation it is usually in the range of 380 nanometers to 780 nanometers. So by knowing the speed of light, that is about 3 into 10 to the power 8 meters per second, it is easy to calculate frequency, because frequency is nothing but this speed of light divided by wavelength. So if we do that, we'll get the frequency levels. But we need to understand the decreasing and increasing order of wavelengths of these different kinds of radiation, and also we need to know the significance of each of these radiations. For example, in radio waves are mainly used for communication purposes, long distance communication purposes, especially in the form of satellite communication. Also microwaves are also used for satellite communication, and they're mostly used for the communication, short distance communication like we use in our cell phones. They usually use microwaves. And then we have infrared radiation. Usually, if you know about infrared goggles, they are helpful to see things in darkness. They usually make use of infrared rays or the properties of infrared rays in their production design. And then we know about visible light, and ultraviolet light is very important. It is both damaging as well as very important for various life forms on Earth. It causes skin cancer and various other skin related diseases. At the same time, it gives energy to various animals or minute organisms on Earth, but they work better only within a certain range. Beyond that range, they are harmful. And then we have X-rays, which are used in X-ray photography, or etc. And then we have gamma rays, which are also important ones, especially in radioactivity and related concepts. So we'll study about these things in general science topic. For now, just remember a few concepts. But this is definitely a very important diagram for your prelims. And then moving on to factors affecting distribution of temperature, we'll see what are the important factors. The first important factor is inclination of sun's rays. We know that Earth is spherical in shape. To be specific, it is geoid in shape. And due to this spherical shape, the intensity of sunlight received at various latitude is different. For example, at the equator, the sun's rays are straight or direct. As a result, this kind of rays, the intensity of these kind of rays is very high, whereas at the poles, due to slantiness of rays, that is, they are spread along a very large area. As a result, their intensity is comparatively much lower. As a result, temperature keeps on dropping as we move from equator towards poles. And the other important factor is duration of sunshine. So for understanding the concept of duration of sunshine, you need to have a good understanding about latitudes and longitudes, and we need to know about how the Earth is tilted, and we need to know towards which direction the tilt is during different seasons. So if you have this idea, the concept is very simple. For example, in summer, usually the northern hemisphere receives light for a very long time. For example, the Arctic Circle is under perpetual brightness or light for about 6 months during summers. Not exactly 6 months, but ranging from 1 to 2 months, it has complete light, whereas the light magnitude or the time duration of light falls as it moves from summer to winter. The exact opposite happens in the southern hemisphere. It is under perpetual darkness during, that is, winters in southern hemisphere, and in summer again, just like northern hemisphere, when it is summer in southern hemisphere, it will be having continuous daylight. So this is mainly due to two reasons. One is due to the tilt and the revolution around the sun. So I've explained in detail in my previous video, so watch the video on latitudes and longitudes for a better understanding. And then other important factor is transparency of atmosphere. So before understanding the transparency, we need to know about the constituents of atmosphere, which I've already did in my previous video. We have seen about greenhouse gases, and there are various other aerosols. Aerosols are nothing but very fine particles of very small dimensions like smoke, soot, etc. And then we have some other important constituents like water vapor and other important greenhouse gases. So all these gases directly affect the distribution of temperature. For example, transparency, coming to transparency, when the whole atmosphere is transparent, there is greater intensity of sunlight. Whereas when the atmosphere is not so transparent, then usually there is huge amount of scattering and reflection happening. As a result, the amount of sunlight received will be low. So here let us see a concept about scattering. Let us imagine there is a particle. It has certain radius, and then the wavelength of light. So this is nothing but wavelength. From here to here, this is wavelength. So when the wavelength of light is greater than the obstructing particle, it simply gets scattered like the blue light gets scattered. And if the wavelength is much higher, much larger compared to the scattering or the obstructing particle, then just like the red light, it simply enters the atmosphere without any scattering. That is, this will be a direct ray. So in other case, when the radius of the obstructing particle is much greater than the wavelength of the entering ray, in such a case the ray will undergo reflection. That is, it comes and returns back to space. So there is no transmission towards Earth. So this the entry and exit mainly depends on the obstructing particle and its radius, and also the wavelength of light, but the wavelength remains constant. It's the radius of various particles that changes. So why we see the sky in blue? Because it's because of scattering of blue color, which is greater. Why is this so? Because the obstructing particles in the atmosphere have wavelengths comparable to the wavelength of radius comparable to the wavelength of blue light. As a result, blue light gets scattered in all directions, and this is why the sky appears blue. Whereas coming to red light, its wavelength is much larger. As a result, it is not influenced by any such obstructing particle and simply directly enters and leaves this particle hitting the earth. As a result, there is no scattering of red, and that is why we don't see red except when we look at sun. This is because only sun's rays are coming directly towards, that is, only red light from the sun is coming straight towards the earth, whereas other colors get scattered, especially blue, in a at a very high range. So this is the explanation behind the blue color of sky, and I'll give a detailed account about scattering and other optical phenomena when I'll explain this section in general science. So the next topic is land-sea differential. So how does land-sea differential affect temperature distribution? We know that land has a specific heat which is much lesser compared to water. Specific heat is nothing but the amount of heat energy required to raise the temperature of a unit of a substance when the same amount of energy is supplied. For example, let us take a kg of water and then a kg of iron, and let us assume that we are supplying the same amount of heat for both iron and water, and the time required to raise the temperature of iron is much less, whereas the time required to raise the temperature of water is much greater. This is because the specific heat of water is much higher, whereas the specific heat of iron is much lower. And when we compare water and land, the specific heat of land is comparatively lower, whereas the specific heat of water is higher. So when there is difference in the amount of land in different hemispheres, for example, in the north we have greater amount of land, whereas in south we have less land and more oceans. As a result, here the time taken by water to cool or get hot is very high, whereas in the northern hemisphere it is comparatively low because of greater amount of land present. So land gets hot and cold very quickly, and it releases this heat in a very small period of time. As a result, this heat is absorbed by wind, and this wind flows along oceans. So there is greater amount of heat exchange between continents and oceans in the northern hemisphere. As a result, the temperatures mainly depend on the temperatures of continents. For example, in summer the continents are very hot in the northern hemisphere. As a result, the oceans are comparatively at a greater temperature, whereas in winter temperature compared to the southern hemisphere, whereas in winter the oceans are cold, the continents are very cold. We are talking only in taking into consideration only northern hemisphere, and as a result there is greater transfer of coolness from continents to water. As a result, the oceans are comparatively cold when compared to the oceans in southern hemisphere. So we can see this is how the land-sea differential affects temperature distribution. And then we have prevailing winds and ocean currents. Both these are important because they are the ones that transfer energy or heat from one latitude to another, usually from the lower latitudes to higher latitudes. As a result, they play a very important role in distribution of temperature on Earth. So we'll see about ocean currents and winds in a different section in a very good detail. So for now, let's just remember that the heat transfer from equator to poles and poles to equator mainly takes place due to ocean currents and winds. And the other important factor is altitude. We know that at ground level the temperature is comparatively higher, but as we move towards the top of a mountain or a high region, the temperature usually falls, and the fall in temperature is about 6 degrees Celsius for every increase in 1 kilometer height. That is, as we move upwards by a distance of 1 kilometer, then the temperature fall will be about 6 degrees Celsius. So this is what is called as adiabatic lapse rate, about which we'll study in detail later. And the next important factor is slope. So aspects of slope is a very important concept. Again, to understand this, we need to know about the apparent position of sun. We know that sun apparently moves along equator. As a result, there are regions which might be under constant shadow of a landform due to the apparent movement of sun. For example, let us consider two mountains, one in northern hemisphere and the other one in southern hemisphere. The sun will be moving along the equator. This is apparent path of the sun, and we see that the sun's rays hit the southern face of mountain in the northern hemisphere and the northern face of the mountain in southern hemisphere, and the northern face in northern hemisphere and southern face in the southern hemisphere are under perpetual shadow of the mountain. As a result, they receive comparatively little amount of sunlight. For example, these regions. So due to lack of sunlight, usually the vegetation growth on this slope is comparatively much lower, whereas on the other slope where there is huge amount of sun's rays, the forests thrive. So this is because of the aspects of slope. So this picture explains in detail. So the north face in both the hemisphere, in southern hemisphere and south face in the northern hemisphere receives direct sunlight, whereas the opposite faces are under constant shadow of these mountains. So coming to next important topic, which is called as heat budget. Heat budget is nothing but how the Earth balances between the incoming radiation and outgoing radiation. How the Earth keeps a constant temperature range even though it receives abundant amount of energy from sun. So let us assume that there is about total 100 units of heat which is received from sun, of which about 6 units are directly reflected back to space by atmosphere. So these 6 units are reflected back to space by atmosphere. So the light which is coming is reflected back in the form of light. So there is no conversion from light to heat, like as we see with the Earth's surface. And then there is certain amount of, after atmosphere, it's clouds. When clouds get the sun's rays, about 27 units are reflected back into space, and snow-capped mountains reflects back about 2 units into space. The reflection is nothing but when a light falls on certain object, it gets reflected back in the form of light. So this is reflection, and this total amount of reflection accounts to about 35 units which are lost directly into space even before being absorbed by the Earth. And this amount of energy which is lost in the form of light back into space is called as albedo. So this concept is very important. And the albedo of Earth is 35 units, of which 6 units contributed by atmosphere, 27 by clouds and 2 by snow-capped mountains. Of the remaining 65 units hit the surface of Earth, of which are moved towards the surface of Earth, of which 51 units are absorbed by Earth's surface, and about 14 units are absorbed by atmosphere. And of the 51 units which are absorbed by atmosphere surface, the total 51 units are transmitted back into space in the form of heat, of which 17 units are directly radiated back into space, and about 34 units are absorbed by atmosphere, and all this absorption by atmosphere is reflected back into space, and this accounts to total 65 units which is reflected back into space. So this is what heat budget is, that is the total energy received is equal to the total amount of energy lost. So this is how the earth keeps a constant temperature range even after receiving so much of energy from sun. So what is the difference between the sun's reception of light and earth's transmission of radiation? We have seen that we receive sunlight in the form of ultraviolet radiation, that is in the form of light. The earth absorbs certain amount of this radiation, about 51 units by earth and 14 units by atmosphere. Even atmosphere is a part of earth, so we consider all this as a part of earth. And all the 65 units which is absorbed by earth as a whole is reflected back into space in the form of heat. So earth is nothing but a heat converter, I mean a light converter, which converts light into heat. So it receives heat in the form of light and then converts this light into heat and radiates it back into space. So this is how heat balance is achieved. So let us move to important topic of albedo of different surfaces. So multiple choice questions based on these kind of topics is much natural. And which of the following reflect back more sunlight as compared to other three? The surfaces are sandy desert, paddy crops, lands covered with fresh snow, and then prairie land. Prairie land is nothing but a grassland. So to answer this question, let us look at a table which gives about the albedo of different surfaces. So we have seen that albedo is nothing but the proportion of sunlight which is reflected back without being absorbed. That is, the light which is coming towards is reflected back in the form of light instead of absorbing it as heat. So if we just look at albedo of different surfaces, fresh snow has about 80%, and then we have thick clouds, old snow, desert, soil, thin cloud, grasses, soil, and then we have albedo of crops, forests and asphalt. If you look at this table, the fresh snow has greatest amount of albedo, whereas asphalt has less amount of albedo. So when a surface has great amount of albedo, it simply means that it is a highly reflective surface, that is, it reflects great amount of light it receives. Whereas when a surface has less amount of albedo, it simply means that it absorbs great amount of sun's radiation. For example, asphalt is a major constituent of both concrete as well as metallic roads. So we have urban areas which mainly have asphalt as the main component in its concrete, and this is why urban lands are very hot. That is, there is a concept called heat island, that is where if there is a city, then a surrounding air mass will be very hot compared to the countryside air mass on the countryside. This is because of greater absorption of heat due to concrete which has asphalt as its main constituent. So it is because of asphalt that heat islands are formed. So we can see how this lesser albedo affects the temperature distribution or the temperature range of different regions. So lower the albedo, the greater is the temperature of the surface. So look at this table and try to answer this question. We can see that from the table, fresh snow has the greatest amount of albedo. So the answer for this will be fresh snow. And along with this, let us consider a table which tells about albedo of different planets, in which we'll see the albedo of Mercury is only about 0.1. And then we have Venus, which has greatest albedo, which is about 0.8. And then we have Earth, which has about albedo of 0.35. And then Moon, it has much lesser albedo, 0.01. So this table will be important in answering a future question. So if we just look at this albedo table, we got to understand few important concepts here. We know that Venus is the most brightest planet in the solar system, at least when it comes to terrestrial planets. So it is because it has greatest amount of albedo or great amount of reflective surfaces compared to other planets. And comparatively, Earth has good amount of albedo, it is 0.35. Mercury has completely very less, and Moon, even though it appears very bright during new moon days, but still its albedo is comparatively much lower, and the brightness is mainly due to the shortest distance between Earth and Moon. So this table, just remember, Venus has the greatest amount of albedo, whereas Mars has completely less amount of albedo. Even Mercury has less amount of albedo. Even Mars has significantly small amount of albedo. And due to great amount of albedo, that Venus is the brightest planet in solar system. Now let us look at another question. Consider the following ecosystems: taiga, tropical evergreen, tropical deciduous, tundra. So we have to arrange this in decreasing order of albedo. For answering this, let us look at an albedo map, and also we can make use of the table which we have seen in the previous slide. So if you just look at albedo map, we see that the greener regions are the ones which have less amount of albedo, whereas the red regions are the ones which have greater albedo. If you see, the snow regions has very high albedo, followed by desert regions, and then we have deciduous forest regions which have comparatively good amount of albedo, and then we have evergreen forest regions which have least albedo. So let us look back at question: taiga, tropical evergreen, tropical deciduous, and tundra. If you see tropical evergreen forests, they are thick forests which have a thick canopy. Canopy is nothing but a layer of the top layer of trees, which gives rise to a small blanket-like appearance. So due to this blanket-like appearance or canopy, the sunlight doesn't reach the ground, and the forests have very less albedo. Just take a look at the previous table. So if you see the decreasing order, the tropical evergreen forest as among these has the less amount of albedo. So it is tropical evergreen which has the least. And then compare tropical deciduous. Tropical deciduous as forests which are much less denser, and there is certain exposure of land to the sunlight, and as a result the forest cover is low, and the soil has greater albedo compared to the forest. As a result, tropical deciduous forest will have albedo much higher than evergreen forests. And coming to taiga, taiga has significant amount of forest as well as snow cover, and we know that snow is a good matter which has greater albedo. As a result, the next option will be taiga. So if you compare tundra and taiga, tundra has no trees at all, it has only snow, so obviously it will be having greater amount of albedo. So in decreasing order, if you see, it is first tundra and then taiga, and then we have deciduous and then equatorial. So the question can be repeated with different options, so you need to have an idea about albedo of different surfaces. In this, the answer is B. And next question, consider the following statements. Albedo of an object determines its visual brightness when viewed with reflected light. Albedo of Mercury planet is much greater than albedo of Earth. So here Mercury is not the metal we are talking about planet. And we have seen this table, Mercury has comparatively less albedo compared to Earth. As a result, only option 1 is correct. We have seen that albedo we will just signify the visual brightness of an object. We have seen a region with greater amount of albedo has greater visual brightness, like snow, whereas the region with lesser albedo has lesser visual brightness, for example asphalt. So the next important concept is latitudinal heat balance. So latitudinal heat balance is nothing but the heat balance between latitudes where the temperature difference is quite significant. For example, the equator has greater amount of is at very high temperatures because of the direct rays received from sun, that is the insolation is highest at the equator, whereas due to shape of Earth and also due to increase in latitude, the northern that is the poles have lesser amount of heat reception. So the heat difference between the poles and the equator is quite high, and this difference in heat is balanced by various factors like wind systems and then ocean currents, where these winds and ocean currents transfer excess heat from equator towards poles, and there is much cold in poles, and this cold is transferred back towards the equator by the same wind and ocean currents. So this is how heat balance is achieved. And in the concept of heat balance, we have two regions. One is energy surplus region, other one is energy deficit region. So obviously the energy surplus region would be the equator, the regions surrounding the equator till the tropical temperate regions. Usually these regions receive significant amount of sunlight, and also the sunlight is comes in the form of direct rays. As a result, the temperature here is much higher, hence they are called as energy surplus regions. So energy surplus regions. And then above 45 to 50 degree north latitude, what we have, both north and south latitudes, we have this region which is an energy deficit region because of greater albedo as well as less amount of heat received. So all these factors influence latitudinal heat balance. So here the important concepts are heat surplus regions and heat deficit regions. So based on all this, we'll see about mean annual temperature distribution. And while studying mean annual temperature distribution, we come across a concept called as isotherm. Isotherm is nothing but an imaginary line which joins places having same temperatures. So why do we need to have these isotherms? Because we have seasons on Earth, and during different seasons the temperature distribution is quite different. And to compare temperature differences and distribution, we make use of this imaginary line concept of isotherm in studying the temperature distribution and differences between various seasons. And then isotherms are generally have few important characteristics. They flow along the parallels. Again, we have Earth, then we have various latitudes. Latitudes are parallels. So roughly these isotherms follow the latitudes because the heat received at a specific latitude is comparatively same. For example, if there is a place at this point of the latitude, then it will receive certain amount of heat which will be equal to a place which is at a distance but on the same latitude. But the temperature might vary because of various climatic factors like wind systems and ocean currents and other factors which distribute heat, and there are other factors like slope, height, etc. But in general, what we have is isotherms which are very parallel to latitudes. And then isotherms take sudden bend where land water contrasts are maximum. Usually we have oceans which have temperatures that are moderate, whereas continents have oceans which are extreme. For example, if we take in northern hemisphere, consider this is North America, and then we have Pacific Ocean. Usually the temperature of Pacific Ocean at this region would be about 15 to 20 degrees or even less, whereas in summer the temperature in America, especially let us take USA, then the temperature would be much higher, about 30 degrees Celsius or so. So the temperature contrast between oceans and land is very high at the border. That is, if we take an isotherm, it will take sudden bends at this land-sea borders. And then we have the spacing of isotherms indicate the latitudinal thermal gradient. This simply means that imagine there are two isotherms which are separated by a very narrow distance, and there are two isotherms where the distance between these isotherms is much greater. And the narrow isotherms simply mean that there is quick change in temperatures, whereas the long isotherms or much wider isotherms simply means that the temperature difference between these two latitudes or the change in temperature between these two regions is comparatively much lesser or much lower. That is, even if you travel for a very long distance, the temperature change is much lower. And this is where we end with temperature distribution. And to study about mean annual temperature distribution, we need to know about ocean currents and we need to know about wind systems. So before understanding this concept fully, we'll first study ocean currents and wind systems, and then we'll come back to the mean annual temperature distribution over Earth. And this is the end of the video for now. And next I'll be discussing about wind systems and pressure systems, and then we'll see ocean currents, which are important in understanding temperature distribution depending on seasons. So if you liked my video, please like and subscribe to my channel. I'll be posting more videos on geography. Once I complete geography, I'll start with new subject. And thanks for watching, and this is my blog where you can get all the text files. Thanks again.